The only way to ensure broad acceptance of refugees by countries is based on a sustainable strategy that will allow the entry of Syrian population will not involve an unbearable burden for these countries. Rather, we must devise methods to achieve that Syrian human capital can provide a value for the countries that receive them. Jordan has a systemic problem due to shortage of water, preventing it to grow at high rates. Lack of crude oil prevents to emulate the solution at naps that have the precious energy resource. One solution resolves the needs of hosted refugees in Jordan and the water problem, being mutually beneficial, is the transformation of the refugee camps in industrial establishments that generate an economic benefit for Jordan and the refugees. This industrial system is self-sustaining and would maintain the refugees, giving wealth to Jordan. At the same time, economic development of populations, currently, is due to the combination of the binomial water plus energy. Jordan lacks sufficient water reserves, but has won access to the sea in Aqaba. The technology of water desalination, by reverse osmosis, provides access to large volumes of water, albeit at a high price due to the need for crude oil consumption for the electricity power of desalination plants. However, the current solar PV technology enables significantly lower the cost of production of drinking water, bypassing the lack of access to conventional energy. Having water, greenhouse farms have shown, as in Almeria, Spain, that can produce large quantities of food at low cost in a desert environment. Access, through a pipe, the Gulf of Aqaba, allows to supply seawater that is pumped with PV electricity. An osmosis plant, operated with PV, produces water for human and agricultural consumption. This water would produce food to feed the refugee population and a surplus for the consumption of the Jordanians. Moreover, having access to seawater and oxygen supply can be implemented fish farms. In this type of activity, operational needs are restricted to two: electricity to pump seawater, which in this case is obtained from solar PV, and oxygen for fish's breathing. The PV electricity can pump seawater and operates the VPSA oxygen generator. It is a self-sufficient system. The basis of the whole strategy is based on solar PV. Refugee settlements will integrate PV generators over accommodations for own consumption. This proposal allows, with the financial support of the international community, to create a nucleus producer of food, vegetables and fish, autonomously, without demanding water and energy resources of the Jordanian government. It would create a source of economy, as has happened in Almeria, Spain, which would give Jordan access to a water source and a first-level food industry. Once Syria is stabilized, and refugees would return gradually to their country, Jordan will have a self-sufficient industrial infrastructure of power generation, water and food. Our company, an expert in all such technologies, would donate the use of all its technology patents. Thus, the refugees camp would have a factory of energy technology so that refugees themselves will be workers to build this garden of wealth. Employing skilled labor among the refugees, taught by our company, which was a burden on the Jordanian administration, would become a vehicle for growth. This settlement, in Aqaba, is able to accommodate 250,000 refugees, giving them 100 liters per day of fresh water, 0.5 kilograms per day of vegetables and 0.1 kilogram per day of fish. Each stall has a supply of 1 kilowatt peak for electricity needs of each family. The settlement produces a surplus of vegetables and fishes that allows to generate a flow of €464 per year per refugee. The investment per refugee is of €1,388 in a settlement self-sustainable.